People mistake the overlap between the equipment and the chemical. A lot of people overstep water and the importance of clean, good water and how that impacts not only your wash quality, but your chemical usage, your cost per car based on, that, as well as, the longevity of your friction equipment or even your touch-free equipment. At the end of the day, what does everybody want? They all want to make money as business owners, and what is that magic formula between your water usage and water cost, your chemical usage and your chemical cost, and then your equipment and your equipment maintenance.
Welcome back to Ask the Expert, where we sit down with operators and industry leaders to share insights that help you build and run a better car wash. I'm Dan St. Jacques from Hoffman Innovate It, and today I'm joined by Chris Bossa, Technical Innovation Manager at Simonize. We're talking about how chemistry, water, and system design all work together, and how getting that wrong can impact your wash quality, efficiency, and cost per car. So let's get into it. All right, Chris, well, thank you so much for joining. I think it's probably fair to say that anybody watching this is going to be pretty aware of Simonize and what you guys do. But to start us off, why don't you give us a little bit of your background and how you got to where you are now and what you have going on with Simonize today?
Sure. Appreciate the introduction. So my name is Chris Bossa. I'm with Simonize. I'm currently the manager for innovation and technology for the car wash division. My background originally prior to joining Simonize was project management and car wash installation. Dealt heavily on the equipment side as well as the build outs of the structures. So in my career path now, I have landed with Simonize doing the chemical side, which has proven to open up even more doors now, having the background in the equipment side. So here I am.
A little bit of everything then. So let's jump into the chemical side first. And when we're talking about that, when operators are thinking about wash quality, chemicals obviously fundamental to that. What role do chemicals really play in the overall results, and where do chemicals fit sort of relative to equipment and process itself?
People mistake the overlap between the equipment and the chemical. The chemical actually is almost separate from some of the equipment in a respect, but I think if we go one more step further to the forefront of water, a lot of people overstep water and the importance of clean, good water and how that impacts not only your wash quality, but your chemical usage, your cost per car based on, that, as well as, longevity of your friction equipment or even your touch-free equipment. So with chemistry, you have your high pH, your low pH, you have your sealers, your drying agents, your tire shines, there's all these different added services, upgrades, as well as, the basics. So maybe if we start with the basics, our pre-soaks, your high and your low pHs, what are those made of? Very important. You have your surfactants, you have solvents, you have your builders, your chelating agents. There's a robust chemical makeup within that. And I'm not a chemical engineer. We have a great team of guys that are way smarter than I am with fancy degrees that they know how to put these all together. So we're able to, take the field experience and go to them and say, hey, we're having challenges here, or maybe we're having challenges in different parts of the country, different parts of the world, and they're able to provide solutions. And from there, that compounds into where to properly put your chemistry, how to properly balance your car and the car chemistry throughout, as well as, a proper rinse, get a neutral surface, a dry surface up until, your sealants, your drying agents, final rinses, and then into your drying. Because what does everybody want? Everybody wants a clean, dry, shiny car. So how do we achieve that? And I think just like you said, it's chemical, it's water, and it's equipment. So now, what's the right equipment? And that's the $1 million question everybody has, right? How much equipment? Is it too much equipment? How do I jam all this equipment into a small tunnel or an in-bay automatic? How do I run it faster? Because at the end of the day, what does everybody want? They all want to make money as business owners. And, what is that magic formula between, your water usage and water cost, your chemical usage and your chemical cost, and then your equipment and your equipment maintenance?
So, you list there, if we talk, you're looking at those categories, you're looking at your chemicals, you're looking at your water, you're looking at your equipment. Where or what are some of the common mistakes you see operators make in in any of those three areas or all of those three areas that lead to either issues down the line in terms of, equipment going down or in terms of overall wash quality? What are some common mistakes that you see that are relatively easily avoidable that you come across consistently?
Well, in terms of mistakes, I don't know necessarily that they're mistakes. Maybe the operators are misinformed. Where in terms of mistakes, it would be paying attention to maintenance. Is it working? Is it not working? And if it's not working, what impact does that have? There's multiple in a tunnel, for instance. There's multiple pieces of equipment, different arches. It's a long tunnel. You can kind of get away with maybe potentially having a piece of friction equipment broken. You can shut it off for a few days until you can fix it, but yet still run your cars in-bay automatic. A little bit different because every application plays a role as well as it's multi-used, within the wash package itself. The misconception I think a lot of operators have is, again, how important it is to have properly tuned and running equipment, as well as, good water, as well as, balanced chemical. Using more chemical doesn't always equate to a better car or a cleaner car. It can actually pose opposite, where if you use more chemical, you're actually going to put a film on your vehicle and it's not going to come out as clean and you're just going to be wasting your money.
Obviously, like, operators, for the most part, understand at least a little bit about chemicals and what, especially from the chemical delivery standpoint, what they're trying to accomplish. When you're looking at things like dilution ratio and delivery, how important is that to get that dialed in when it comes to chemical performance and quality as well that you're seeing on the other side?
So pre-soaks, which would be your initial stage, your initial cleaning, the chemical makeup of the pre-soak is very important, whether that be high pH or low pH. And then, there's a large discussion of, do you put low pH on, then high pH, and then low pH? Is it for friction? Is it for in-bay automatic touchless? So there's theories on that everybody has. But the important part is that outside of the dilution ratio, the water plays the very important part, the drive part of that concept, as well as its titration. So titration is where you want to go with your pre-soaks. So the catchphrase these days is super concentrate, hyper concentrate, concentrate. 1 to 1,000, 1 to 2,000, all these great things, right? And then you look at, okay, well, how are we applying this to the vehicle? What are we putting it on with? As well as how fast is your chain speed? So are you applying your pre-soaks appropriately, or are you over aerating or over atomizing where you're not getting a surfactant as a proper build onto the vehicle surface? Just because it foams doesn't mean it's cleaning. And that's a big misconception. Everybody thinks more foam, more cleaning. That's not the way it works. The foam is actually a carrier for the heartbeat of the chemical in the pre-soaks, which is really your surfactants, your cleaning agents. So dwell time is key, as well as water is key, because let's take high pH, for instance, a high pH pre-soak that's mixed with a high grains per gallon water solution is actually not going to clean as well as if you had more of a neutral or 0 grains per gallon or zero hardness in the water solution. So just as important as your titration is, the application of how it's applied to the vehicle is just as important, as well as your dwell time, because the chemical has to be able to react to whatever's on the surface. And again, based on your high pH and your low pH in your titration of the efficacy, or how strong the chemical is, what is it doing to the surface? Now, typically you apply your low pH prior to your high pH because the low pH is harder to put through the high pH. So the high pH kind of will neutralize, or what it does is actually create an exothermic reaction. It kind of heats, which then lifts a lot of the oils, bug residues. There's different reasons why you use high and low pH, your biofilms, your road films. But just as a generic, with the high pH and the low pH, the titration is what is very key on that, and not so much your dilutions, how much you're using. But again, if you really want to dig down into it, start with your water. water is the most important. Start with your water, then titrate your pre-soaks. The dilution ratios is kind of just a big fugazi at this point.
You talked about dwell time, and something I want to touch on, because I know a lot of people are moving to smaller and smaller tunnels as land becomes kind of harder to come across here, and it's tougher to build, the large 180 foot, 200, whatever it was going to be. How important is it then to be considering chemical dwell time when you're laying out your tunnel? Because I think, there might be people who their initial assumption or their initial plan is going to be, let me throw as much high pressure, as much friction in this space as I can, because that's what's going to get it clean. When really you're talking about what you're really doing now is reducing the efficacy of your chemicals, because now half the time you're washing it off before it's even had a chance to properly dwell and actually apply to the car. So how important is that when you're laying out your site to be considering where your chemical applications are?
So layout is very important, and it starts with the machine layout or the applicator layout within the tunnel. Fortunately, again, working for Simonize, we have over 8,000 SKU numbers. So we have a big library of chemicals to pick from. So having that being said, we can adjust and modify our chemical program for anybody's car wash based on the way that their equipment is set up, as well as the way that their water is set up. What I've seen just from installing car washes is that everybody's very focused on, when the equipment's going in, when the building's going to be done, when we're going to get the certificate of occupancy, but nobody ever took a water sample prior to sticking a shovel in the ground and saying, do I have enough water? Is the town going to let me use all this water? How much water do I really need? And what does the water look like? So, that plays a big part, because if you're not rinsing, just as important it is as putting the chemical on, rinsing the chemical off and rinsing the biofilms and the road films and the bugs. And, this time of the year with winter, you got your calcium and your magnesium chlorates that are, used as the magic salts on the roads. So it's a big, kind of mathematical formula of how do you get to that end result. So to go back to how important it is on the layout, we can modify and we can adapt. The dwell time obviously is ideal. However, with friction, there's different ways that we can modify the chemical structure to apply onto the friction equipment, which not only cleans, but provides that lubricity so you don't get the swirl marks and, all the negative PR that tunnel washes get these days about, causing damage to vehicles. But again, it still needs time. So if you're running your belt speeds so fast that the cars are, flying through your friction and they don't have enough time to really agitate and dwell, then sometimes we can modify chemically, but sometimes it means maybe, slowing the belt down, or, the equipment's only made to go so fast. But there's been a lot of kind of innovation in the equipment side of the world these days that allows, for those faster chain speeds, for the faster wrap speeds with the friction, which again, we've modified our chemical structure to, or chemical formulas, to account for that.
So let's stay on the topic of site planning, obviously, because you have been involved on that side of it too. What are some other things you talk about? Okay, have you even checked the quality of this water? Which seems like that would be the first place you would go, but it's easy to understand how that would be overlooked in the process of, like, I just want to get this building up and running, get this thing going. What are some other things that you see that are often overlooked by either operators when they're looking to build, or architects or contractors, your GCs? Is there other things in there that you often see are overlooked when someone's establishing a new site?
Well, I think equipment room space would jump out as number one. How are you going to fit all this stuff in an equipment room, as well as even the tunnel? I know everybody has the working windows or the areas that the equipment should be put in, and everybody likes to draw these fancy pictures. But in the real world, when you start bolting things down to the ground and you're watching the top wheels come down and the wraps go out and cars go through and, rollers or conveyor belts, is it laid out appropriately, or did someone sell you a whole bunch of equipment that just got smashed into a small box? There's always that it looks good on paper, but what's it really doing on the job site? How many times I've seen 100, 120 foot tunnels, and then you get there and go to measure it out, and the concrete measures at 93 feet or 97 feet. And it's okay, not only how do I equate for 17 to 25 feet of less space to put the equipment in, but how are we going to modify the track, or how are we going to modify the belt, or, what does that do for the whole environment? And then into the back room, it's okay, so what is the water that's being provided? How much water is being required? What happens if you have 3, 4, 5 cars in the tunnel and everything's ramped out, ready to go? High pressure tanks are trying to fill at 50, 60 gallons per minute. Is it a 2-inch pipe? Is it a 4-inch pipe? Is it 50-foot run, 100-foot run? So there's a big hydraulics calculation that kind of needs to be done, but seems to always fall short a little bit. But I think, to kind of the original question, a lot of the oversight also is the maintenance of things. Everybody wants to do it cheaper and faster, but that doesn't always equate to cheaper in the long run. So with taking the water samples, are you better off putting in a water softener now, or finding out, a month after open, after you've had your kind of grand preview, and you're going, I can't get a dry car. Well, yeah, because you have hard water. Or I can't get stuff to foam. You have hard water. Now they got to put a softener in. Now it's an added cost. Where do you put it? Nobody accounted for, the footprint of a water softener going in. Or reclaim. Reclaim's a big, at least in the Northeast, is a big conversation these days, especially for getting initial permitting. Did the tanks that were put in equate for the overturn? Is the filtration system able to keep up with the demand of the car wash, as well as the demand of filtering the water for the car wash? So there's a lot of different moving pieces. What works for one person might not work for another site. Even guys that are multi-site owners, what works for one site might not work for another site. And you just got to figure that out.
And that's the point you make about the initial savings. I think that speaks to, for us on the equipment side as well. I think it's easy to say, here's an initial savings for me, without doing, like you're saying, the legwork of what does this mean in the long run? Because a lot of times when you're looking at cheaper equipment options or cheaper options within your wash, most of the time that's going to mean it's going to be more expensive down the road. So really building that out to understand, what will this actually save me in the long term, instead of just getting open to get up and going. I think that's, it's something always worth considering. So, I mean, when you go to a site where a car wash is being planned, are there certain characteristics that you say, okay, I'm excited about this site, or it has strong potential, or certain characteristics when you're defining just before everything is laid out, yes, this makes sense for a car wash itself?
I mean, I'm just the chemical guy. So, in terms of the equipment and the layouts, but if someone's willing to have a conversation, an open ear conversation about things, I love to be able to go through and make suggestions, or be able to provide solutions, as well as, the relationships that Simonize has with equipment manufacturers and other industry leaders, to be able to confidently suggest or propose certain solutions makes it a lot easier for us. And like I usually say to guys, I'm like, 1 + 1 will always equal 2. So a lot of this is our basic math problems. How many gallons of fresh water are you using? How many gallons of reclaimed water are you using? How many gallons of soap are we using? How many cars are we projecting? So we can kind of go through and forecast some of these things if site owners are willing to sit down and kind of have that quick conversation. And a lot of these guys are building them faster than they can sign the documents sometimes. So it's a fast-paced world, as well as everybody wants it done tomorrow. The longer you're closed, the more revenue you're losing. So you want to get open, but you also don't want to be closed because of oversight and putting out a bad product or a bad car, or that your equipment's breaking because somebody overlooked a certain issue. And I think one of the things too, and just talking to guys that have been doing it 20, 30 plus years, is most car washers are washing an exceptional volume of cars these days. The equipment years ago was kind of built for 40,000, 50,000 cars a year. Now guys are doing that in a month. So there's a lot more maintenance that needs to be involved. And, that's also what we've taken a look at Simonize is developing our chemicals for that mindset as well. So as the car wash or the need for the ability to wash more cars has come into play, which means they want to do it faster. Modifying our formulas and working with working with manufacturers of equipment to align some of our chemical with that, as well as, how do we make the water better outside of just mechanically filtering it? Are there ways that we can chemically modify the water or enhance the water? Or, we came out with our Nanobubble program, which has gained great traction and reputation over the last year. And, we continue to look for strategies and technologies in conjunction with our relationships with equipment manufacturers and even installers, distributors, all across our networks to continue to provide the top solution for our customers.
So, I mean, you touched on reclaim there. I want to go back to that. Obviously, that there's a bigger and bigger push now when you're building new car washes from municipalities, from local governments, the requirements to have reclaim. Obviously, being in the Northeast, it's a big part of what we do here. So where are you seeing reclaimed water, make the most sense for use in a wash? How have you seen that used? And what do you think that kind of the best applications for reclaim is when using it in the wash?
So kind of a broad question, because we have to go back and look at what does the operator want to do? What's the operator willing to invest into? And kind of, what's the short-term and long-term, gains for the operator? Reclaim water right now for some of my top customers, they're using it on everything, including chemical, except for final rinse. And final rinse could be an RO. Final rinse could even be, a nanobubble infused rain bar with street water. So every site is different. It always starts with taking a water sample, seeing what's in the water, what potentially is going to cause issues, whether it be for chemical or rinse or equipment, and then aligning it with a chemical program. And then again, it's kind of a math equation of how much reclaimed water can we filter based on the current setup. Do we need to upgrade it, or can we upgrade the current setup? What does that look like? How many tanks do they have? How big are the tanks? How many cars are they washing? Because even though the water's coming out as reclaimed water, you still have to be able to filter the water prior to reusing it. So a lot of the mechanical side of the reclaim tanks is they want to settle or gravitationally settle the sediment as it goes through. But if you're pushing the water through too fast, then you're not able to gravitationally settle that turbidity out of the tanks. So again, are the tanks big enough? How fast can we mechanically filter it through some sort of filtration system? Is the filtration system the right system based on the water sample? And then, are the chemicals aligned and balanced? Because a lot of people skip over looking at the chemicals. They think chemicals are just cleaners. Chemicals are chemicals. Every chemical is the same. And that's not really the case. You can have different surfactants. You get the congealing, you get that kind of gum residue that goes on there. You get clogged nozzles. And, then that translates into aerobic bacteria. So you walk into some of these tunnels and they kind of smell like rotten eggs. They smell, a certain way. That's from the bad bacteria, the bad bacteria growth. So you have to balance everything. And again, just a big math equation. So how much water are we putting on the car? How much water are we taking out to reclaim? Are we reclaiming the water fast enough to put back in? Can we chemically modify the filtration system in order to clean more water faster to use? And then, downstream, is that water or reclaimed water good enough to mix with chemical? Is it good enough to rinse on the car? Traveling all over the country, everybody uses it for an undercarriage, and they use it for, anything lower than the glass on the side doors. And, they're putting it on high pressure, and they're almost doing themselves a disservice because you're really just throwing dirty water back on the car. And a lot of it is, it's, the sewer fees, or, is it a closed loop system? Is it a sewer bound system? The closed loop systems obviously pose a challenge, because you have to recycle that water over and over and over without overfilling and then having to pump out, because there's that extra cost of pumping out. So can we filter the water appropriately and fast enough so that the car wash can continue to use that same gallon of water over and over and over? Kind of like a big fish tank, basically. Eventually you have to add water, take water out, filter water, change the filtration. There's kind of a whole maintenance side of things. But in terms of the reclaim water, with our RX line, which is our reclaim line, some of the other products that we're offering, some of the other products that with our Nanobubbles we've now launched. I mean, we're able to offer most car washes, 96 to 97% reclamation water, and using a minimal amount of fresh water or RO water as a final rinse for the vehicles, and still getting great quality.
So I think we'd be remiss if we didn't dive into the topics of nanobubbles a little more. Obviously, I think that's been kind of one of the bigger developments in the industry, and you see it popping around a lot. It kind of ends up being a buzzword. I think a lot of people kind of understand conceptually what it's doing, but if you can give everybody kind of the simplest definition or explanation of what exactly is a nanobubbler doing, what is the purpose of nanobubbles, and what are they? What is that doing for me?
So nanobubbles, as a scientific definition, are ultra small gas bubbles, 200 nanometers in size. To relate that, it would be basically smaller than like a grain of sand. So very, 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 very small. You can't see it with the naked eye. Where their ROI comes into is that they are ultra condensed gas bubbles, where their surface area has what they call a zeta potential. So they stay suspended in the water column, rather than like typical air bubbles that come up and pop. And where that becomes of value is that it's able to increase the ORP and the dissolved oxygen within the water column. So it's basically making the water itself healthier, to simplify what it is. But in stabilizing the water molecule, it actually provides for a covalent bond or a secondary bond onto the H2O molecule. So it's harder for any sort of dirt, oil, surfactant, to penetrate into that purified kind of water molecule. And then what we've been able to do is develop this with our chemical lines, but also with a company called Chemical Reduction Solutions, that we've created a hydrodynamic cavitation device that also electromechanically ionizes the water, single pass. So what that does is it basically negative ionically charges the water, as well as expands and collapse the water molecule, providing these nanobubbles, very, very small, in the billions and millions of volume saturation within the water column, which then we've been able to work with our lab and come up with different chemical reactions, basically, that we can use with pre-soaks, drying agents, water rinses, reclaim, and reclaim cleaners. So it's really enhanced the solutions that we've been able to make, as well as, because of the negative ionic charge, it neutralizes the minerals. So if you have hard water, it doesn't filter anything. It basically neutralizes. So it's almost like a magnet or a battery, the plus and the minus. So it's still kind of out there, in the water, but it's not going to attract or magnetize to any sort of surface, which is great. So we've seen great results with injector longevity, and injectors not fouling and failing, which provides for consistent chemical pulls from those nozzles not clogging, especially high pressure nozzles for reclaim. So reclaiming water typically being a little bit dirtier and not fully filtered. So now having the ionization with the nanobubbles does that. But one of the biggest things is it removes the surface tension within the water column as well. So the solutions, like your drying agents, ceramics, your carbonates, are now fully homogenized inside that small tube that goes out to the tunnel. Whereas before you kind of had, probably a little bit of chemical, because the viscosities, it sits all kind of funky. Then you're hitting it with air and it's blowing apart and all that. So now you're able to get a full solution onto the vehicle surface. And by that, being able to lay, when you activate it with your final rinses, you're actually getting a better sheeting. You're getting a drier car now. You're not going into the dryers with as much contact water on the vehicle surface. There's less static water on the surface, which is now, you're not blowing off 2 gallons on the car. You might be blowing off a half a gallon. So it doesn't require more dryers. The cars are a lot drier coming out. And then to the chemical side with the pre-soaks, the alkalines actually get excited to the point where they foam more. And by doing that now, you can remove some of the anionic agents that people tend to look for, because the anionic agents foam better, but those are also the ones that are the biggest offenders for reclaim, where they create more bacteria. So, it's a big environment circle of, again, back to kind of your math equation of where can we put them? How do we do it? And then, what's the value, the return value, not only to the customer, but, on the maintenance side and things like that.
So what does that integration process look like right now? So are you talking about reclaim, obviously chemical dispensing as well? How and where are you primarily putting these nanobubblers, and what does that look like if an operator was looking to add that to their current setup?
So we're putting them everywhere. So they don't require electricity. They don't require, a lot of plumbing work. They're very easy to install. No maintenance. There's no filtration. I mean, it's a tube that gets put in. It gets flow mathed based on the application. We have them in in-bay automatics, touch-free and friction. We have them on RO systems. We have them on chemical injection systems, hydrominers, dositrons. We can put them anywhere. We put them on shower heads in houses. We can put them, I have 3 of them on my house. I have hard water. I don't need a water softener anymore. So there's a lot of value in what it was. And it took a lot of research, and it took a lot of testing and field testing and engineering to get this product to where it needed to be. And now we're in the second phase of diving into, with the nanobubbles, the cohesiveness of combining that with chemical and modifying the chemical to get better returns, and even better, shinier cars than we were getting before. Because of the reduction in surface area, we've been able to scale back the amount of water used per car, which is a huge value to everybody in the environment, and especially going in front of some of these boards to get permitting. That we're kind of changing the game now with what is the standard or the norm for not only how much reclaimed water you can use per car, but also how much fresh water is required to properly rinse and chemically applicate per car. And one of the great products that we've paired up with is the innovative dispenser that does a great job. All stainless. We put the nanobubble on there right after the Grundfos pump, and we've had great results with that. Thorough breaking, reduction in final rinses. I mean, to the point of reducing some of these RO rinses in half. So just it's been very positive, and our customers have agreed with us, and we just keep on pushing the boundary of where this can take us.
And so for the quantifiables then, for someone putting in a nanobubbler, saying, where can I expect to see results beyond just saying there's going to be part of it that's just going to be visual and me saying the cars look different than they did before? And I think part of that's just experience of understanding what your cars look like when you've been producing them. But you touched on it. I mean, water usage, chemical usage, odor, those sort of things. Which odor, I guess, is hard to qualify or quantify, but what are the sort of immediate measurables that an operator could look at and say, here is the impact this is having on my bottom line?
Well, in terms of the bottom line, that's for the operator to decide. They obviously don't share their P&Ls with us. But that being said, one of the questions always is, all right, how long until this pays for itself? Well, that's a bigger question too. That's like saying a cost per car, right? Cost per car. Oh, it's 30 cents cost per car. Well, is that a blended average? What are you putting in it? How many chemicals? How many arches? Does that include tire shine? There's so many variables for these catchphrases in the industry. So when we break it down and we look at it, let's kind of segregate it. We have, your RO and your final rinse. That's kind of a finished section of the tunnel. Then you have your drying agents, your ceramics, your graphenes, your carbonites, waxes, polishes, that part of the tunnel. The reclaim side of things, which, like I said, most people are using undercarriage and just, side jets, rocker sprays, where with Nanobubbles and with our reclaim program of chemicals that we've now been able to kind of flip the script on that and been able to use the reclaim water not only more times over, because we can filter it and clean it better, and balance it. But now we can add it to pre-soaks. We can add it to wrap rinses. We can add it to, HP pre-soaks. You can put them on the top. You can put it on the side. Again, every car wash is a little bit different. We got to look at what's there. If it's an older reclaim system, are they using ozone? Are they using, 5, 25, 50 micron filters? Are they backwashing the filters? Are they using the right tanks? Are the tanks actually working? Is the ozone working? So conversation is a lot bigger, but what it does is opens the door for improvement and enhancement at a small investment. It seems like everything in the car wash business these days is $100,000. How much do that's 100,000. We're talking $3,000 or $4,000 to implement some of these. And again, no electricity, no maintenance, no filters. Set it and forget it. And we're warranting them up to 5 years right now. And again, it's a bigger program than just you put this in and boom, you're done. But if we want to look at putting a lot on our dispensers, we've taken out a lot of different hydrominers, dosatrons, hydroflexes, gone into the dispenser. The dispenser does a great job of accurately and consistently integrating chemical and water, through the Venturi system, and adding the nanobubbles to it. We're getting better foaming, but additionally to the foaming, it's dwelling faster. So I think we talked about this, 20, 30 minutes ago, where how is that dwell time? Well, now I'm encouraging people to turn their conveyors up, because we can get not more chemical, but we can get a better solution of chemical with the nanobubbles onto the vehicle surface, enhance the reaction to lift and pull. And because they're nanomicroscopic bubbles, they're getting into the pitting of the glasses. They're getting into all the little crevices, that typically your friction or even some of your soaps wouldn't have time to get into. And they do act as a natural cleaner because they are carrying that negative ionic charge. So we're seeing crisper and cleaner glass come out now. Everyone's like, oh, how'd you get the glass so clean? Everybody thinks, we turned up the ceramic or turned up something, right? Nope. That's so there is a lot of visual to the nanobubbles. On the reclaim side, you would see, there's different ways that we can test it. We test the pH, test the ORP, test the TDS, the TSS, the EC. There's different, stuff that I'm still learning through our chemists and whatnot. But there's different ways that we can show numbers, right? Everybody wants quantifiable. I get it. But we're also infusing something into the water that you can't see. So we've done a lot of the testing. We have the big fancy certifications that say that these work and these are making nanobubbles. And that's all well and good, because what does the customer want? Well, I can't see the nanobubbles, so how do I know if it works? Well, there's a lot of visual to it, but then ROI, talk to me in 30 days. Did you have to replace your injectors like you normally do? Were you able to turn your water softener off? Are your cars coming out cleaner? To start turning down soaps isn't something that the chemical guy wants to say. And I could probably, I'm going to get a lot of trouble with the bosses, but we're able to tweak the soap concentrations, So back to our conversation about the pre-soaks with the titrations. The titrations now, we might not have to run them as heavy to break through because we're now ionizing the water. So again, back to the original conversation of water. How important is water? We're ionizing, enhancing the water. We're ionizing, enhancing the chemical. We're ionizing, enhancing the reclaimed water. We're using more reclaimed water instead of fresh water. So you can kind of already pick and choose where all the savings are coming from. And one of the biggest savings that quantifiably would be up to the operator is to see how many membranes on like an RO system that they're not having to replace because the membranes aren't fouling as fast. One of the products of the nanobubbles is that they kind of provide a protection coating on the inside of the piping because of that charge. So you don't get all that biofilm buildup like in your tanks, like your hydromizer tanks, your high pressure tanks. There's usually kind of that foam scum, or you have that residual congealed carbon MSO product on the side. So with the nanobubbles, you're not seeing that anymore. Or I've had guys with, they go in and they say, oh, it usually takes me 10 hours to jet down my pits and clean them all out. And I got to use this chemical and I got to wear a Tyvek suit and do all this stuff. Now they're basically using a little bit of hot water and a high pressure spray and they're spraying from the top on the D-box and boom, 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 boom. And it all comes off because that reduction in surface tension. So, the buildup is a lot slower than it typically was. So they're not having to clean them out as much. So there's another, savings on the P&L. How many times did you clean out your pits last year? Once a month. Now, the funny part with that metric is if they tell you it's a monthly schedule, you got to think a little bit because it should be based on the car count, right? Because it's how much water is going through your system total until basically the water's too dirty to manipulate. But a lot of the operators are looking at how much water they're using on the undercarriage and the side jets to just kind of discharge and evaporate the water and then how much fresh water they're bringing in. And it's typically more fresh water than the reclaimed water. So they're not really looking at the mechanical filtration part of things for the reclaimed water because one, it really has no impact on the quality of the car because they're kind of just spraying it somewhere where you're not really going to see anyways, as well as the fresh water is diluting and kind of filtering the reclaimed water. So now pick a site that's a closed loop system where every gallon matters and not overflow or discharge somewhere else. Chemical, the water, the equipment, the nanobubbles, everything plays a part in that. So huge ROI on nanobubbles for sites like that. And we've done a bunch of sites that are closed loop and have testimonials for that as well.
Yeah, I think, I think it's an important point. You've made it like several times throughout this conversation that it's not a magic bullet because there is no magic bullet in the car wash industry. This is things where you have to be evaluating everything else upstream and downstream from the changes that you're making because the problem isn't probably occurring just in one spot. There's probably more going on there. So an nanobubbler is not going to solve all your problems if your infrastructure isn't right on the other side or in all your other upstream and downstream applications before it.
Correct. And that's why it's important too for, we have the relationships we have with distributors, installers, manufacturers to have that conversation and with the Nanobubble program, to encourage them to make it OEM because it does help them just as much as it helps the chemical guy, as much as it helps the operator. A lot of operators are busy. A lot of car washes are super busy. Maintenance is an oversight for a lot of people. Don't fix it until it's broke, where there is no maintenance on the nanobubbleizers, but also because of the enhancement that the nanobubbles have for your water, your reclaimed water, and your chemical, it causes less fouling of your injectors. It causes less fouling of your nozzles, your rain bars. You're not getting algae growth. There's so many different aspects that I could name of what the ROI is, other than you're going to save $1 or you're going to save $5, you're going to save $5,000, because every operation is different and how everybody approaches it is different. So kind of going back to I want to provide solutions for people. So when we go into these washes, and if they want to have the conversation, if not, I'm okay just being the chemical guy. So, but it's been real eye-opening to be able to travel all over the country and talk with operators and for them to kind of open their doors and have that open conversation, or even to say, this is how we do it. Can we do it better? Which is pretty awesome.
Yeah, I think, another important point you made there, I think the car wash industry, especially, I think you see that it's not one size fits all. So whether that's equipment, whether that's chemical side of things, no one operator is doing it like another one. So I think it's important always when you're evaluating those type of things, chemicals, equipment, all those things, to understand that maybe there's another way of doing it that works for you that doesn't work for somebody else. And you don't necessarily want to put yourself in a corner, put yourself in a box of, here are my only options. So it's important to, for partners like Simonize, the same way that we do, reach out to those partners, see what they can maybe help you with or do something different for you when, there's variability in these sites, there's variability in all these washes. And clearly, you guys are willing to do that and help them out and help them provide the best car possible.
Yeah. And we're very fortunate. I'm very fortunate to be part of the Simonize team. And I've seen a lot of the relationships and the longstanding relationships, generations of relationships that we have as a company with not only equipment manufacturers and distributors and clients and operators. So to have the conversations of the operations and for all people to kind of show a little bit of vulnerability in it, because it's, the private equity and the roll-ups and, I'm not going to show you what I'm doing and I want to be secretive and all that. It's been really eye-opening to at least take that feedback and then be able to, go to my bosses and say, hey, this is what I'm thinking, and this is what, I think we can excel on or enhance, or can we enhance? Can I talk to the chemist and say, hey, this is the challenge that we have out in the Midwest. This is the solution. This is what I'm thinking for a solution. Can we do it? Okay, let's look at it. Let's form a plan and then, make it actionable. And I'm batting 1,000 right now, but I'm still working it out. I'm sure I'm going to have some failures and that's just part of it. So at least we're trying. And we're trying to provide the best that we can. And status quo is not good enough for me. I want to make sure that we're exceptional and able to provide exceptional chemical, for our customers.
That's great. So, just to kind of end here, because what do you guys, what's on tap for Simonize this year? What are you guys looking forward to in the next sort of 12 months, 18 months, or anything coming down the pipeline that you're excited about?
We're full steam with this Nanobubble program. We spent about we released it at ICA last year. The mechanical side of the product itself is selling itself at this point. Everyone has confidence that it works and it's doing what it's doing. Now we're enhancing that performance with a dedicated chemical lineup for Nanobubbles, as well as a dedicated chemical enhancement for reclaim systems. We already offer our RX products, which is great, reclaim friendly, reclaim compatible. But now with the Nanobubbles and digging deeper into it, we're going to be chemically enhancing the reclaimed water to filter even better at a lower cost and replacing membranes and whatnot for operators. Second to that, we released our ChemCheck system. Our ChemCheck system is an inventory management system, live updating, shows your chemical levels, shows your inventory, shows you your cost per car, shows you how many cars you have left in a drum, shows you if your injector's working or not. I mean, there's so many upsides to this offering that we have, and it's taken the better part of the last 18 months to work with the programmers to put this all together and have a robust solution that is not just an AI generated nonsense product for our customers, but our customers expect exceptional chemical from us. So any sort of product offering or enhancement offering that we have coming out of my division of innovation and technology, I want to make sure is right on that level. And so this ChemCheck system is phenomenal. We just had it at the Southwest show, received great feedback. We're going to have it at ICA. So there's a dashboard with login, and it's going to be great. Just real positive rollouts, and our customers have been giving us very positive feedback on these two programs, the Nanobubbles and the ChemCheck system.
That's great. I look forward to seeing that at the show in May. Well, Chris, thank you so much for your time. I mean, I know you're a busy man, washes don't stop, but I appreciate the crash course. I think I'm definitely smarter for hearing all you had to say. I think anybody that watches this will walk away feeling a little more confident about their understanding of their chemicals. So thanks again for your time, Chris. Really appreciate it.
Appreciate it.
All right, thanks, Chris.